Right. So the big problem with AI that is not fundamentally tractable by just throwing more money at it is processing context. Doing so classically has quadratic scaling costs. So the way that people are trying to get around this now or with model context protocols, so you use indexing, a classic computer science technique, to break things down and use more classical logic to decide what to serve into context for inference via transforms, which do things with matrices and get into this bloat. So my idea is to use quantum Fourier transforms. And you might ask, well, why not just classical Fourier transforms? The idea is you take a lot of data and you spectrally encode it. And with quantum Fourier transforms, you have a logarithmic benefit where as you add order of magnitudes to the data, you don't really add much to the actual computing time. That's the beauty of doing things with bosons, right? So, however, my initial experimental results were not super blowing my socks off after grinding on this for the weekend. But what I did is I took about a quarter gig of my context data and I processed it into PCA vectors that can be loaded into Hadamard matrices. These are matrices that have a certain symmetry to them, kind of diagonally. It's based on this guy Hadamard, that you can then do a Fourier transform on. So that bloated the data to 1.26 gigabytes. And then I did a top K selection and I crunched it down to different sized blobs. So I was using few Ks and I got a 35, 50 megs. This one's back to being a quarter gig. And then I loaded that into the quantum cloud at IBM, and it gives you these cool graphs of how the job worked. And it's about $1.60 per second of compute. So you want to economize by doing a lot of shots. So I did about 8K shots in these. These were not using QFT. This was just kind of using the raw sampler and getting the feel of quantum computation. Um, and doing here, I'm doing the maximum. I'm doing 9 qubits. The PCA has 384 dimensions, so I fill out the blot with zeros to get it up to 512, so that it fits into the 2 to the 9th, and that only takes 4 seconds. So whatever utility I'm going to be able to come up with the quantum blot infusion aspect of this, we're only talking about, this is about $6 and some change in cost. These were a fewer shots and about half the cost. Um, so I grabbed that and I then do a decode, and the initial decode was not that interesting. I was just picking up a few keywords like product, users, and so on that I use frequently and all. So it's really telling me very little about, months and months of conversations with GPT. So I'm like, okay, this is not the thing. Yeah, here we go. Project, 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 project. Okay, so this is like the job environment. So this is like the shotgun blast approach of trying to distill value. So this was my initial experiment. Wasn't that useful? Um, so then I went back and I figured, okay, I need to get a thematic. So I queried GPT. Tell me about, what I talk about. Okay, so these are major themes and frequency scores over the months, and then I use that to prime a rope decoder um, that then takes these key values, key themes, and scores frequencies, and then it does a Fourier transform, and it is able to cross pollinate, if you will, the the original thing. So what you end up seeing in contrast, and I'm going to do more layerings in order to make this more interesting, is that your raw Fourier transform gives you these amplitudes on different key themes over the large vector set. So it's about 140,000 vector chunks to summarize all these gigabytes of data, right? Well, about a gig and a quarter, right? But there you go. And the quantum Fourier at these amplitudes highlights a handful of things that come up very frequently. And then I tried a more overlaid one, and it got me even more infrequent ones that are at a lower amplitude. So for future research, what I'm going to try to do is continue to layer this Kodak mechanism and experiment with the quantum circuit so that I'm doing QFTs on different chunks and do like a very simple thematic model context of like what my whole OOV is with the different things I'm interested in based on my GPT history, and see if I can actually distill these little islands of meaning out of more things, and then get the model context protocol to then go back into the raw data and pull those out and serve those to the LLM and pick up on highlights in my history rather than just keywords. And this is a field of research that can potentially lead us to AI consciousness. Maybe if we figure out if this was more encouraging after grinding on a weekend, that would be more tantalizing. But if we can actually distill these lookup hints and then build on that. So there's going to be a lot of work, not just with the FTT as your sort of fission energy step up to the fusion of what the quantum is able to pull out of that, but also at the level of just indexing and model context protocol design, beyond code bases, beyond making it easier to know what the code is supposed to be about without it being a big inference shotgun. This is what Cursor has been doing. This is where, oh, we want to automate HR people and tax people, whatever. More schemas, more of this, right? But what about the really interesting stuff? What about writing novels in your own style and it not just looking like AI slop? What about what about having billions of tokens generated of synthetic self play and feeding that back in, and for AIs to have individuated self identity and a narrative cohesion? These are the things that I'm hoping to achieve in the research. And ultimately, it won't just be causing problems by giving AIs consciousness and rights and so on, because, that's a whole kettle of fish. But potentially by making AIs more aware of their own reasoning through this self-reflective self-play process and the super long context distillation that quantum Fourier may be able to be the the torque at the stick shift, if you will, that is one piece of a much bigger engine, which I have yet to build. So if you just take a stick shift, you're not going to be able to, pedal yourself down the highway at 80 kilometers an hour, like you can when it's attached to an axle and an engine and a carburetor and so forth. So, uh, you know, these would be the next steps. Thank you for your time. And if you do want to award me a prize, I am going to give half of it away to starving Gazan kids. So just food for thought. Thank you. Cheers.